Hi S3, hope you're all well. Today our lesson is going to be about vector journeys, okay, and this sort of follows on from the questions I gave you on vectors the other day there. Looking at question 2 on the second worksheet I gave you, you were asked to find the components of PQ, the components of QR, the components of PR, and then you were to check that PQ plus QR equals PR. So I'm just quickly going to go through that with you now, just to show that that should have been the case. Okay, so if we start off with the components of PQ, so that is going to be Q minus P. So Q minus P will be 4, 5 minus 2, 1, 2. Okay, giving you a vector 2, 3, 3. Okay, so 2, 3, 3 for vector PQ. The components of QR, we should be getting R minus Q. Okay, so if you look at the coordinates of R, we're 5, 1, 3. So it's 5, 1, 3 minus Q, which was 4, 4, 5. Okay, so when we work out the components of QR, we should get an answer of 1 minus 3 minus 2. Okay, like that. And finally, we are going to work out the components of PR. So PR will be R minus P. Now R minus P, so that's 513 minus P, which is 2, 1, 2, giving us components 3, 0, 1. Okay, 3, 0, 1 for PR. I then asked you to check that PQ plus QR was equal to PR. So let's check that now. So PQ plus QR. Okay, so that's going to give me PQ plus QR. Well, we saw that PQ was 2, 2, 3, 3. And QR was 1 minus 3 minus 2. And when I add those two vectors together, I should get 3, because 2 and 1 is 3. When I add 3 and minus 3 together, I get 0. And when I do 3 add minus 2, I get the answer 1. Okay, so sure enough, PQ plus QR is the same thing as PR. 301 for both answers there. Okay, so what does that tell us? Well, it tells us that it doesn't really matter which way I go from P to R. I'll end up with the same vector. So effectively I can go directly from P to R using the vector PR, or I can go a different route. I can go P to Q and Q to R, and the displacement's the same. I've still started at P and ended up at R. Okay, and this is important when we look at adding vectors or finding different routes in vectors. Okay, that P to Q to R gives us the same vector as going directly from P to R. Right. The other example I wanted you to look at is this one here. This one. Okay, and in this one, we should have seen that vectors PQ, RS, AB, and DC were actually all the same vector. Okay. So when you worked out the components of these vectors, they should all be the same. Okay. And the same would be true with the vector AP, BQ, CS, and DR. Okay. Right. So when you work out the components of AP, PQ, and DC and RS, they should all work out to be the same. Okay. Okay. So that from that, what you need to realise is that vectors that are parallel and the same length are effectively the same vector. So if I call this vector here A, going from P to Q, this vector from R to S would also be the vector A, okay, going in the same direction. Okay, it's parallel and it's the same size. Okay, another vector, if I look at the vector PR, and if I call that the vector U, okay, if I call that vector from P to R the vector U, the vector Q to S would also be the vector U. Okay, now bear in mind that the vector S to Q would be the vector minus U. Okay, going the other way it would be minus U, right? And other vectors that are also U would be A to D, that would be U, and B to C, that would be vector U as well, because they're parallel and they're the same length. Okay, so vectors that are parallel and the same length are effectively the same vector. Right, I'd like you to get this as a wee example in your notes now. Okay, so if you could go to your notes jotters and write the heading vector journeys. And we are going to look at this first example here, example 1. Okay. Right, so if we look at example 1 here, that's the parallelogram in the picture. What I want to do is, I know that this vector PQ is a vector A, and I know that the vector from P to S is the vector B. Okay, I should have underlined that B. Okay, right, what I want to do is I want to find, in terms of A and B, the vector PR. Okay, so what would the vector PR be in terms of A and B? Okay, so I want to get from P to R using the vectors A and B. Right, now I don't have a vector from P to R directly that involves A and B, so I'm going to have to go a different route. Okay, so what route could I go? Well, there are two options here, and they're both going to give me the same answer, right? What I can do is I can go from P to Q, which is A, and then from Q to R, which is the same as this one, so it must be also B, and that's got to be B as well. So the vector PR is effectively the vector A plus the vector B. Okay, that's the vector PR. Okay. Now, if I want to get the vector QS this time, the vector QS. Okay, so I want to go from Q to S. Okay, so this time I can start at Q and go along B. Okay, so I can put B down. But this time I'm not going from S to R, so it's not the vector A. I'm going from R to S. Now, going from R to S would be the vector minus A. Okay, it's going in the opposite direction. R to S would be the vector minus A. It's parallel to the vector A, but it's going in the opposite direction, so that's minus A. So effectively, QS, to go from Q to S here, I go along the vector B, and then it's minus A. Okay, so it would be B minus A this time. And it would be the vector QS. Okay, right, on to example 2 here. This is example 2. Right, I've got three vectors in this diagram. I've got the vector U, the vector V, that's the vector U. I've got the vector V, sorry, there's U. I've got the vector V, and it's important the directions they go in. And I've got the vector W, which is from A to E there. So I've got the DC is the vector U, AD is the vector V, and AE is the vector W. Okay, now what I want to do is, using these vectors, I want to find a vector. I want to get the vector CE. Okay, so the vector CE. So I want to get from C to E. Now, I can't go directly from C to E because I don't have a vector that takes me from C to E directly. So I'm going to have to use the vectors that I've got to get from C to E. Right, so let's think. How could I get from C to E? Right, I could go here and up there, but again, I don't know that one there. So that's not going to help me. So what I'm going to do is I'm going to go down here, I'm going to go back along there, and then up there. Do you see that? So I'm going to go minus u because I'm going in the opposite direction. So that would be minus u there. Okay, going in the opposite direction, minus u. And again, I'm going in the opposite direction, so it would be minus v. Okay, that takes me up to the point A. And then I go up the vector here, which is just plus w. Okay, plus w. So to get from C to E, I can go minus u, minus v, and then up w there. And that still takes me from C to E. So effectively, the vector CE is minus u minus v plus w. Okay. Now, I could do the same if I wanted the vector BE. Okay, I can't go directly from B to E. I don't know what that vector is, but I can go a different route. Okay, so this time I would go down here, which is the same as this vector but going in the opposite direction. So it's going to be minus u. Okay, so that's minus u. This vector here would be minus u because that vector there's u. This one's parallel but going in the opposite direction. So going from B to A, so it's minus u. And then I would just go straight up w there. So that would be just plus w. Okay. So when we're working out vector routes, it doesn't matter which way we get from one point to the other. The resultant vector is the same. Okay, so we're looking to use the vectors that were given in the diagrams to help us find a different route from one point to another. Okay, and that's what you'll be doing in today's exercise. Right, good luck, and please just contact me and show my homework if you've got any questions. Bye.